Okay, today in this lecture we will study the new topic, and that is Cauchy Euler equation, and this equation is also known as equidimensional equation, and the general form of the linear differential equation makes an equidimensional equation or Cauchy Euler equation is form is a, and I'm writing in the descending order, a n dn by dx to the power n plus a n minus 1 dn minus 1 by dx minus 1. This is the standard form of the nth order linear differential equation. And if I multiplying here x to the power 1 along with the first derivative, multiply x square, and here I am multiplying x to the power n minus 1 and here x to the power n, then this linear differential equation becomes a Cauchy Euler equation or an equidimensional equation, where an and an minus 1 and so on, these are not the functions, these are just right? So we will consider now up to the second order. So second order Cauchy Euler equation is a2 x square d2y by dx square a1 into x dy by dx plus a naught y, and I am 0. Okay, so this is a standard form of Cauchy Euler equation, and I just want to represent a, b and c because these are constants, so we can change. So I am writing it ax square d2y by dx square plus x dy by dx plus c into y equals to 0. So this is the second order Cauchy Euler equation. Okay, like a higher order differential equation, homogeneous differential equation, how it is solved. So what is its method of solution? That the solution is whenever these x term is multiplied, x functions are multiplied according to the derivative along with it, then the solution is of the form y equals to x to the power m. Now we are not dealing with the e to the power mx. We have the solution here is y is always of the form in the Cauchy Euler equation. Solution is always of the form y equals to x to the power m. So if we take the first derivative, then it becomes y dash equals to m x to the power m minus 1, and if I take the second derivative, then it becomes m into m minus 1 x to the power m minus. I will substitute this second derivative, first derivative and simple y in this Cauchy Euler equation of order 2. So this is Cauchy Euler equation of, so I am replacing here the values of second derivative, first derivative and simple y. So replacing the value of y double dash, it becomes ax square m into m minus 1 x to the power m minus 2, also plus bx m into x to the power m minus 1 plus c into x to the power m equals to 0. From here we are constructing the auxiliary or characteristic equation. So because x has the same base, so powers are always added, and if I take these bases same, then it becomes x to the power 2 plus m minus 2, 2 and minus 2 gets cancelled. I am writing it like this, plus m minus 2, so it gets cancelled, and e into m x to the power 1 plus m minus 1, so it gets cancelled, and c x to the power m. Now the equation is reduced to m minus 1 x to the power m plus b into m to the power m plus x to the power m equals to 0. Okay, now I am because x to the power m is the common term here, so I am taking x to the power m common and rest of the terms are multiplied, and it becomes am square minus am plus bm plus c equals to 0. So here m gets common, comes x to the power m am square plus b minus a into m plus c equals to 0. As we know that if either m is 0, even m is 0, or any integer, any rational, irrational number, we know that x to the power m can never be 0. So that means this term 0. So this is the auxiliary equation of Cauchy Euler equation of order. Okay, so this we have auxiliary equation, and am square plus b minus a into m plus c equals to 0. So this auxiliary equation can be solved, or the root can be solved with the help of quadratic formula, and quadratic formula will decide according to this: b minus a whole square minus under root 4 into a into c divided by 2. So discriminant will be b minus a whole square minus 4ac. This is the discriminant here. So depending upon the discriminant, we will select the roots. First case is if we have real and distinct root. That means if one root is y1 equals to x to the power m1, and second root is y2 equals to x to the power m2, then the general solution is basically it is a complementary solution. So general solution YC of Cauchy Euler equation is C1 x to the power m1 plus C2 x to the power m2 for real and distinct roots. Okay, case is when you have real and repeated root. Y1 equals to x to the power m1, m1 equals to m2, and y2 also has x to the power m2. So m1, that means equal roots, repeated roots. Then what should you do? You just have to make the solution, that is general solution yc is c x to the power m1 plus c2. Now you don't have to multiply x, you have to multiply it natural log of x into x to the power m1. This can be solved, this can be sought out with the reduction of order techniques, and there is a complete story behind that natural log of x. So in Cauchy Euler equation, remember that you have in the repeated roots, you have to multiply this natural log of x instead of simple x. Okay, so this is real repeated root. And third case is conjugate complex in the term of when iota is involved, and in the terms of m1 is alpha plus iota beta and m2 is alpha minus iota beta. The general solution is the complex conjugate roots is in the simple homogeneous equation, higher order equation, you have to write e to the power alpha x, but here you don't have to write e to the power alpha, you just have to write x to the power alpha cos. In that you write beta x, but here you have to write beta natural log of x plus c2 x to the power alpha sine beta natural log of x. So here is the complementary solution of the Cauchy Euler equation. So these three are case. Example number 1 is x square y double dash minus 2x into y dash minus 4y equals to 0. Now extract there are two methods. Either you can replace suppose y equals to x to the power m and then y dash and y double dash, you can construct the auxiliary equation out of that. But here I will do the simple auxiliary equation, that is m square plus b minus am square, a means 1, and b minus a is minus 2 minus 1 into m plus c equals to 0. Here a is 1, b is minus 2, and c is minus 4. Or you can do this substitution and you solve this all. Okay, so that makes it minus 3m minus 4. So if I factorize it in this form, m square minus 4m minus plus m minus 4, that makes it the roots are m minus plus 1 and m minus 4. So here are distinct and real roots. One is minus 1 and one is 4. So general solution is c1 x to the power minus 1 plus c2 x to the power 4. So here is the answer. Now we come to the second example. Second example is example 2. 4x square y double dash plus 8x y dash plus y equals to 0. So I can construct, you can substitute y equals to x to the power m and solve this and construct the auxiliary equation. I am just constructing its auxiliary equation by selecting a here is 4, b here is 8, and c here is 1. Okay, so the auxiliary equation is a m square plus b minus a, 8 minus 4m plus c equals to 0. So that makes it 4m square plus 4m plus 1. So that makes a plus b whole square, 2m whole square plus 2 into 2m into 1. So that means m plus 1 square equals to 2. So m must be minus 1 by 2, and because there are two roots, so m must be m1 equals to m2. So here are repeated real roots. Okay, so the general equation is yc equals to c1 x to the power minus 1 by 2 plus c2 natural log of x to the power minus 1 by 2. So that is the solution.